Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on electric field from March 2022, Paper 4, Variant 2. In this question, we will discuss what is represented by electric field lines. Then we will discuss how to find, means how to calculate potential at any point between two opposite charges. Mean in the region between two opposite charges, how we can calculate value of potential. Then we will discuss about electric field between two opposite charges. We will also sketch a graph of potential versus distance. And at the end of the video, we will also talk about what is direction of force on an electron if it is placed at equal distance from two opposite charges. So we're going to discuss some very important points about this chapter in today's lesson. So listen carefully. First of all, try to do question by yourself and then look at the solution. For part A, we need to state what is represented by electric field line. Let's try to understand this one with the help of positive charge, means the electric field around a positive charge and electric field around negative charge. So let's say we have negative charge here. So here we have negative charge and this is the electric field around this negative charge. They have the equal amount of charge. So that's the reason we simply draw 4 for electric field line. This also tells us that they have the equal amount of charge because they have equal number of electric field lines. Now, if I need to draw direction of electric field lines here for positive charges, we draw pointing away from positive charge. So we draw arrows like this, pointing away from positive charge. But for negative charge, we will draw pointing towards negative charge. We draw arrows like this. This is what question is asking you. Why we draw these arrows like this? For positive charge, we need to understand why we draw away from positive charge. We follow one convention. Convention is that if we place a positive charge nearby any charge, so these lines tells us direction of force on positive charge. In this case, you can see this is a test charge, this is a small charge. So it does not affect the electric field of source charge. So this big charge we call this is source charge. Test charge is very small. Test charge. So the force on this charge, you will see it is pointing to the right. So that's the reason we draw these lines pointing away from positive charge. If we place test charge here, test charge has to be positive. So again, repulsive force between these two and the force is pointing upwards. And same it is true if we place here, anywhere you place in the electric field, the force will be pointing away from positive charge. That's the reason when we draw these arrows, we draw pointing away. And same is true for the negative charge. But if I place again test charge here, test charge is always positive. If I place positive test charge here, the force on this positive test charge, this is to the left. So that's the reason we draw this arrow to the left. Now, if we place positive charge, test charge here, there will be attractive force between positive charge and this negative charge. So test charge will be attracted. So that's the reason we draw arrows pointing towards negative charge. So that's the thing you need to understand to answer this question. So simply electric field lines tells us direction of force on positive charge. In this case, direction of force on this positive charge is to the right and here it is to the left. So this is what electric field lines are telling us. And that's all what we need to write down for this question. And so this is how you can write down your answer. So simply you can say electric field lines tells us direction of force. So you will get 1 mark, 1 B mark. And if you have mentioned on positive charge, you will get second B mark. And there are 2 marks for this question. For part B, it is given to us there are 2 point charges P and Q and charges are placed at a distance of 0.120 meter apart from each other as shown in figure 4.1. Charge on P is positive charge and the magnitude of charge is 4.0 nanocoulombs and charge on Q is negative and the magnitude is 7.2 nanocoulombs. For this question, we need to determine the distance from point P of the point on the line joining the two charges where electric potential is 0. Means we need to find a point at a certain distance from P where potential is 0. It means the value of V is equal to 0. Potential is equal to 0. Let's say that point is at a distance of x from P. We just assume a certain distance x, and then we will find the magnitude of x. Means the value of x we will find out. And let's say this distance, if this distance is x and the total is 0.120, so the distance between Q and that point will be 0.120 minus x. Now simply we need to find out what is value of x. Now, first of all, let's try to understand a little bit about potential. For positive charges, so I will write down for positive charges, the potential of positive charge is positive. For positive charges, potential is positive. So I will simply say potential is positive. Why potential is positive? Because V is equal to KQ over R. If Q is positive, it means V is also positive. Very important point. You need to enter sign. Very important point. For negative charges, we can also say for negative charges, potential is negative. So we can write down here. For negative charges, V is negative. Why V is negative? Because V is equal to KQ divided by R. If Q is negative, it means V is also negative. So simply we can say positive charges produce positive potential and negative charges produce negative potential. Or simply you can say potential of positive charges is positive and potential of negative charges is negative. Very important point. Now let's try to answer this question. It is given to us that we need to find the point where potential is 0 due to these two charges. So first we write down the potential of P. So we will say the potential of P plus potential is a scalar quantity. So Vp plus Vq has to be equal to 0. Now Vp we can find out, means the potential due to positive charge, that is Kq. I will simply say K times Q. Q in this case is 4 nanocoulombs. So this is 4 times 10 to negative 9 coulombs divided by distance. Distance is equal to x. Distance is equal to x. So this is plus sign. So let me clean this one and rewrite. So this is plus sign here. And this is negative charge. So the potential of this one will be negative. So we will use negative sign here. So this is negative 7.2 times 10 to negative 9. And this is divided by the distance. And the distance from this point, I mean the distance between charge and the point is 0.120 minus x. Now from here, the first thing, there are few things we can cancel out. The first thing we can cancel is the k. I'm just using k here, but k you need to understand k is equal to 1 over 4 pi epsilon naught. You can also enter 1 over 4 pi epsilon naught. To keep it just simple, I'm using k. So we can cancel k with k. And the power 10 to negative 9, we can cancel with 10 to negative 9. Now we can simplify this. If we simplify, we're left with 4 divided by x here, and this is negative here. So on other side, this will be positive. So this will be equal to 7.2 divided by 0.120 minus x. Now, if we cross multiply, it means we multiply like this. Cross multiply. If we cross multiply, in this case, we will get 4 times 0.120 minus x. This is equal to 7.2 times x. And from here, we can find out, means the value of x will be 0.043 meters. And this is our final answer. Our final answer has 2 SF. Because the least number of SF in data, we have 2. So we are using 2 SF here. So this is our final answer. This question has 2 marks, and the first mark you will get if you have written Vp plus Vq is equal to 0. Means you have entered value here. So this mark will be C1 mark. And the second mark is the answer mark if you have got the right answer. So this one is answer mark. For our second part, we need to state and explain without calculations. Means we don't need to do any calculations for this part. Whether the electric field is zero at the same point at which the electric potential is zero. This question is a bit tricky one. This is testing your understanding of electric field and potential and the relationship between electric field and potential. So first of all, let's try to understand what is the relationship between electric field and potential. Electric field is equal to negative of potential gradient. So simply we can say this is equal to negative delta V over delta R. Now this is the distance. So electric field is the negative of potential gradient. So electric field is zero if the gradient of V against R graph is equal to 0. Means E is 0. If the gradient of this one means delta V over delta R, this is 0. So simply we can say if the gradient of V against R graph is equal to 0. If the gradient of this one is 0, it means that electric field is equal to 0. If the gradient of V against R graph is equal to 0, it means electric field is 0. Now let's try to sketch first of all electric potential against R. First of all, we will sketch potential against R graph. So V against R. In this case, we have two charges. One charge is positive and one is negative. So I will place the positive charge here, means this positive charge. So it is placed here. And I will place, let's say, the negative charge, it is placed here. So this one is the negative. So simply let me draw here. This one is the negative charge. This one is negative charge. So this is negative. Positive charge. Its potential is positive. So potential V is equal to KQ over R. Mean R is the distance from the charge. So as the distance from the charge is increasing, the potential of this one will decrease. Now if you look at the negative charge now, the potential of negative charge, this is negative. So it will have certain value, but this value has to be greater because its charge is greater. So its potential will also decrease with distance. But we will see at certain point the potential due to these two charges, we will get graph like this. I mean, if we combine the potential of these two, at this point you will see the potential due to these two charges is 0. But if you look at the gradient of this one, gradient is not 0. So it means at this point potential is 0, but electric field is not 0 because the gradient is not 0. So electric field, we will say, at this point is not equal to 0 because electric field is equal to negative delta V over delta R, and this is not equal to 0, means the gradient is not 0, but V at this point, this is equal to 0. And that's the point you need to understand to answer this question. So potential can be 0, but at that point electric field cannot be 0. Now let's try to answer this question based on electric field concept. So we will look at that certain point again, and at that certain point we have discussed potential is equal to 0. Now we will look at this point again and we will find out electric field due to positive charge at this point, and we will find direction of electric field due to negative charge at this point. If you look at direction of electric field at this point due to positive charge, so this will be pointing to the right. So we will say this is direction of electric field due to positive charge. Now if you look at electric field at this point due to negative charge, we will write down this is also to the right because electric field lines are pointed towards negative charges. So electric field due to Q is also to the right and due to P is also to the right. So it means the net electric field at this point is the sum of these two fields. So the net electric field will be somewhat like this. So this is our net electric field. Electric field is a vector. So this is our net electric field. Means the sum of vector sum of these two fields. This is not equal to 0. So simply we can say in this case net electric field is not equal to 0 because fields due to P and Q, they are in the same direction. So that's the reason E net is not equal to 0. Even potential at this point is equal to 0. And that's all what we need to write down for this question. So this is how you can write down your answer. And in this answer, this is your statement. So you have to write down this one in your answer because question is asking you to state and explain. So this is your statement and this one is explanation. So if you have stated and you have explained, you will get 2 marks. Actually, for this question, we have 1 mark. In order to get this 1 mark, you should have the statement in your answer, meaning you have mentioned no and you have explained why it is not 0. So you will get 1 mark, and this is B mark. For third part, it is given to us an electron is placed at point X and it is at equal distance from both P and Q as shown in figure 4.2. Means electron is simply placed at this point and it is at equal distance, means the distance between electron and P and the distance between Q and electron, they are the same. But the charge on P is plus 4.0 nanocoulomb, means it has positive charge. But Q has negative charge and this is equal to 7.2 nanocoulomb. As distance is the same, but charge is different. So the force on electron due to Q and due to P will be different. But force due to Q will be greater. So we will draw 1 arrow here. Because these 2 charges, they have the same charge. It means there will be repulsive force on electron. So this is force on electron due to negative charge Q. And the force due to charge P, this will be attractive because these 2 are opposite charges. So the force will be in this direction. So this is attractive force. I draw this arrow shorter because force due to P is weaker than force due to Q. So this is simply, we have these 2 forces, these are acting on this electron. We simply need to sketch actually, so it doesn't matter. The length of arrows is not very important. To just give you idea how we will draw the resultant force on this one, I have drawn 1 arrow. This is longer because this force is greater and this force is weaker. Now simply we need to add these 2 forces. So we will use parallelogram method. So I will take this vector from here. I will just draw here. So I will be using dotted lines. So this is direction of force. Now we will take this vector and we will place here. And now we need to find the resultant of these 2 vectors. So the resultant is from the tail of these 2 vectors to the head of these 2 vectors. So simply tail to head. So we will join this one here. And this is direction of resultant force, and you can see this resulting force is below horizontal, and that's all what we need to do. Simply you need to draw this arrow. So this one is the resultant force on electron. But if these 2 charges, they were equal in magnitude, then the resultant force will be along horizontal. But in this case it has to be below horizontal because repulsive force is greater than attractive force. So this is how you can draw the resultant force.